Okay, so I apologize for the delay in the start today. We were trying to fix all the computers and have them working perfectly for you, and that stuff takes time to get through all of them. But SketchUp 2015 is now on all these computers, and it should all work, which is the idea. That's a good thing. The other thing is Dropbox is now running on these computers with a special account that I created so that when we get to the kind of more advanced network renders, when you have to leave it and you can't do it just during class, you leave it running, it will auto-save into a folder that you can then pick up later without having the computers restart and you lose your rendering. So there's strategy involved in getting this stuff to work. So anyway, we're going to start today with exercise 213, which was actually what I was planning on doing on, I guess it was Monday when things didn't work. So we, and I guess all the way back to last Wednesday, when I had to give you the sample file instead of letting you pick an actual site. So we're going to start from the very beginning in getting a site from SketchUp, and then we'll walk all the way through the beginnings of kind of how you create one of these cardboard 3D topo models, which is a good way of, one, testing your Rhino abilities, but two, if you learn this skill well, you can bust out a topo model in about an hour if you have access to a laser cutter. It glued together everything, once you master the techniques. I could probably do it in a half hour to 40 minutes. So it's a fast thing. I used to do these a lot in grad school. You don't have to obviously laser cut it. You could cut it by hand if you're building a bigger model than what can actually fit. But these are really convenient. They don't take a lot of cardboard to make. It takes 2 sheets out of the laser cutter, maybe 3. So it's really fast because they're hollow on the back sides. And this is something that Rhino does really easily. I'm going to show you how to make the Rhino files to do this, and then we'll also go through how do you actually make the physical, cut them out, glue them together, etc. So this is essentially what you're making for your assignment 202s, which are due in a while. You can tell that some of them can get very complicated, very steep. It's still very doable to do that. This one's not the best example because the little the base doesn't quite match up with the topo lines. But some of these other ones are far better, where you can see that the sides match up perfectly and hold. So anyway, we'll talk about some of the details about how to make those a little bit later. But let's start in the basics of how we're going to get the terrain information. So depending on our site, we may be presented with an AutoCAD file that has topo lines in it, and we're going to build it from that. In this class, we don't have surveyed sites or anything like that. We're going to use the information that comes in SketchUp, built into SketchUp, to generate the terrain. It's an approximation, but it's a reasonable approximation, and it'll get us where we need to go for this class, certainly. And it'll get you the bulk of where you need to go for the other classes as well. So I'm going to go ahead and I open SketchUp 2015, and under Template here, I'm going to pick the architectural design in feet and inches as my template. It doesn't really matter as long as you're in feet and inches because we're going to want to stay consistent in the workflow. So I'll go ahead and say Start using SketchUp, and this will bring up the SketchUp window. Your SketchUp may look different than mine. That's differences in the computers and whatever. The only button we really care about is right here. It looks like a little folded map button. That's the only button that we care about for right now in SketchUp. And actually, I don't really need this little dude looking at me, so I'll go ahead and select him and press Delete to get rid of him. But I'm going to click on this folded map icon, and when I click on it, it should bring up the Add Location dialog box here. We can go ahead and close this little pop-up window, and then this is a matter of typing in a geographic location, or we could just simply start zooming in, and at a certain point we could find ourselves, for example, we're right in here somewhere, right in there. There we go. There we are. Hello. Right? Yes. No, we fixed that. Okay, jump to a different computer. And what number machine is it? Number 4. Okay. I may be able to fix it also, but so anyway, we can pick any location. What I'm going to ask you to do for your work here is to pick a location that has some hilliness to it. And if you pick, I used to have people pick Yosemite, but a lot of Yosemite has cliffs, like Half Dome is a cliff, and it's really hard to build topo of a cliff. So instead of doing that, pick something a little bit more reasonable. The site is actually up to you. If you have a specific site you want to pick, if you you like being in the mountains, you can pick Lake Tahoe. I'm going to pick something for right now over in the hills. I don't know, we'll pick something like this. As we zoom in, you can kind of see a reference of what the hills look like. That one looks like it might be kind of interesting, those little valleys in there. And then once we get to a set of hills that we like, we're going to go ahead and click on this Select Region button. And when we click on the Select Region button, we get a rectangle of our site. If we're zoomed out too far, you see how that white box shows up? That's the maximum amount of terrain I can get from SketchUp. So if I'm at the black box, or if I'm at the white box and I click Select Region, it's going to force me into that size piece of topo. If I'm zoomed in more, I have a little bit more flexibility, and I can grab the pins and adjust them a little bit. We can move where we're selecting it. So let's say I want it to be like right there. I'll go ahead and click on Grab once I have it, and it will come in as a flat object in SketchUp. Okay? I'd like to see what this looks like and see if I like it before I move on. So I'm going to go to the File menu. I'm going to go to Geolocation, and I'm going to click on Show Terrain. And when I do that, I'll get a terrain model of what this looks like. Okay, so if I use the Orbit command, I can look around and see what that hillside looks like. And it's kind of interesting, I guess. You know, maybe I want something a little bit more mountainous, so maybe I'd pick a different file. I like to do them in separate files, so let's go ahead and say no. And let's do this one more time. This is good review anyway. Let me click on the geolocation, and this time let's pick like Lake Tahoe. Zoom out here a little bit. And so we might be able to find something with a little bit more terrain here. Let's see here. Pick a different computer. And so let me go ahead and select region. There it is. And I'll click on Grab. And now I can go to File, Geolocation, Show Terrain. And we can say, OK, that one actually looks a little bit more interesting because I get a little bit more mountain, a little bit more terrain. So again, it's entirely dependent on where you want to pick it. But the point is to get this kind of 3D view. Once we have this view in SketchUp, this is all we're using SketchUp for. I'm going to go to File and then Save As. And to be safe, I'm going to go back to SketchUp version 7 to make sure that it will actually come into Rhino OK. I believe that Rhino has updated, and we can probably bring in up SketchUp 2013, but I know that 7 works, so I'm going to go back to 7. And I'll name this something like Mountain Topo. And I'm going to save it to my flash drive. And let's see here. This, what are we on? 213 today? Yeah. X213. And I'll go ahead and click a save. So this, by the way, is all written up. If we go to the digital tools site, we go to tutorials. If you go to Physical Modeling 6.1, this is going to walk you through step by step how to create this file that we're going to be working on today, right? It is assuming a little bit more information that we've already created the topo from SketchUp. So if we go to Rhino and we go to Rhino 5.23, this is the SketchUp from, terrain from SketchUp. So you can follow this one along as well to make sure that what I'm doing makes sense afterward. Okay, so 5.23 and then 6.1 are the ones that you're going to be referencing today. Okay, so I've gone ahead and I've saved this SketchUp file. Now it's a matter of opening Rhino. So I'll go and I'll open my Rhino file, and it's going to be large object inches. Perfect. And once I'm inside Rhino, I need to bring in the topo file. So I'm going to go to File and then Import. and I'm going to go to my flash drive. And I'll pick 136 here, 213, and there's my topo. Okay? If you're not seeing it for some reason, you might not have all compatible types. You may be just looking for a specific type. So make sure it does say all compatible types. And then you should be able to pick your SketchUp file. When I click on Open, it's going to bring up the SketchUp Import Options dialog box. And so basically the defaults of this are all going to be just fine. It's going to come in as a mesh. And so we'll go ahead and say OK. And if I zoom out, we'll see that the terrain file that came from SketchUp is now inside my Rhino file. Okay? If I switch my view into shaded mode, we can kind of get a little bit better look at the mesh that represents my file. Go ahead and make it big so we can see it. SketchUp also exports two files. It's the flat version and the hilly version. Remember when I toggled the terrain on in SketchUp, it went from the flat version to the hilly version. Essentially, that's what SketchUp's exporting. I'm getting both. I really don't care so much about the flat version, so I can go ahead and press the delete key and get rid of it. All I care about is the hilly version. Okay? So now that I have the hill version in, this is just like exercise 211, what we did, where we had to make this into an actual piece of NURB surface that we can work with, okay, instead of a triangulated mesh. So I'm going to use the contour command. Right? And again, this is going back to my Rhino 5.23, right? That'll walk you through using the contour command to do this. And what I'm going to do is I'll type contour. It's going to be a contour of this surface. And actually, I should put it on a layer first. Let me go to Layers, move on to Layer 1, and let's rename this X, Y contours. All right, perfect. So that's the active layer. It has the check mark next to it. And I'm going to select my surface and type contour, or go up to curve, curve from objects, contour. And the first, let's see, I need to check vertex so I can get down here at the bottom. First one is going to be, and turn on ortho, in the x direction, which happens to be this way. I'm looking at my little axes there. So we're going to go in the x direction. Remember, I'm not snapping to anything. It's just a straight line going out the x direction. And I'll click. And then the distance between the contours, I don't know, I'll do 100 feet. Okay? And then I'll hit Enter. And I should get a nice division there. Now remember, if I went back, straight back, and I did the contour command again along the y-axis, I get a bunch of little points. Okay, some of you had this happen when you did it last time. It's because I'm then contouring the lines, which gives me points. So if you contour a surface, you get lines. If you contour lines, you get points. Right? So I don't want that. Let me step back here. Oops. Too far. What I want is I want to contour the surface again. So I'll select the surface, contour, start at the same base point here. And this time we're going to go off in the y direction, same distance of 100 feet. And I get that set. Okay? So now, if I were to look at it in the top view, we should see a perfect grid. Let me turn off my Google layers right now. And yes, I'm seeing a perfect grid. If you don't see a perfect grid from the top view, if you see lines that are kind of on an angle, then you didn't do the contour correct. And it's worth going back and redoing the contour. So now let me enlarge the top view here. And remember, I have the ragged edges along the sides, and I need to correct for those. So I'm going to use the trim command, and I'll select, and hold down Shift. Actually, I want to get rid of that one. I'll select curves that are well inside of the edge of my terrain, something like that. Actually, I can probably get away with this one. And then I'll type trim, or go up to Edit and Trim, and I'm going to drag through each side to clean up my objects. And this does take a little practice with how you select. See, I was a little off there. Try it one more time. There. All right. once I have a nice, even, trimmed square, no ragged edges, right, we'll switch back into the perspective view. Okay? And here's where I create the surface. So we've done this before. This is a curved network. So I can go up to surface, curved network, or the key command is network surface. And it's going to say that I have more than 100 curves, and I'm going to say yes, do it anyway. Right? And assuming I did it correctly, I'll get the result with A, B, C, and D on the 4 sides. And then I can go ahead and say OK. And we have to be patient at this point. Even I can't make it go faster. OK, so it finally came on, and I'll see the density here. Now remember, when this happens, it gets really, really slow in the process. And so I'm going to try to zoom in, but I have to be a little patient. And I need to select the surface itself. So I'll keep zooming in, and then I'm going to click on this red. And when I select it, again, really slow, right, it's going to turn bright yellow. And that's because this is such a dense object. Once I get here, I'm going to type rebuild, or go to surface and then rebuild. Or it might be edit and rebuild. And again, be patient. And when I get the rebuild dialog box, this is where I'm going to change the U and the V. And we'll do maybe 100 by 100. Remember, the lower the numbers, the smoother the surface, but you lose accuracy as you do it. So I'll try 100 by 100 and let it rebuild, and that's reasonable. I want the surface to not be on the same layer, so I'm going to change the object here to be on layer 2, and let's rename the object to be terrain surface. And I'll go ahead and turn off the X and the Y contours. So now I'm at the point where I have a nice NURB surface that represents this particular mountainside. Okay? I'm seeing a little bit of the artifacting of the triangulation here. So I could elect to rebuild this one more time at maybe 50 by 50 to smooth that out. It's a choice, how smooth you want it to be. Okay? So there it is. Now I'm going to actually start to build the physical model of this. Right? So this is where I start to build this piece. And so in order to do this, I'm going to be following along with the Physical Modeling 6.1 setup here. And one of the things that's really important, and I gave it to you here, it's printed in your book. This is a cheat sheet for building topography that I made up, this little thing. And I really should have a, let me see if I can pull it up on, so we can look at it up on the board. Okay? So this way you can all see what I'm pointing at. Okay, so what we have here is on the left column here, we have the scale. So if you wanted, say, a 1/4 inch equals a foot, you'd go to that scale. If you wanted an 1/8 inch equals a foot, you'd go to that scale. Right? And like I said, you could do, a lot of times when you're doing topography, it's a big scale. It's 1 to 500 or 1 to 200, etc. This scale is going to vary, and based on the scale that you choose here, right, it's giving you a bunch of information. Okay? So let's assume for a second that we're going to make our final model out of cardboard, like this. Okay? This is the cardboard that you can go buy at the bookstore. Right? Just standard, regular cardboard, nothing fancy. And actually, it's what I'd recommend you build your models out of because it's available, it's cheap, And I think you'll spend $3 on each sheet or something. So it's a $6 project plus glue. It's not bad. Okay, so let's say that we're going to use this material. I need to understand what the thickness of this physical model material is before I can actually chop up the site into its correct size pieces. Okay? So first thing that I'm going to do is I'm going to find out what this material is, and I'm going to measure it really, really carefully. Right? If you don't measure this material carefully, you'd get the result that it's 1/8 of an inch thick. But it's not 1/8 of an inch thick. It's actually 5/32 of an inch thick. It's a little bit thicker than 1/8. So I'm serious. You have to be really, really precise, or it's not going to work. Okay? So this is 5/32. So if I come over here to 5/32, you can see what my contour interval is going to be when I ultimately cut my contours. And I'll come back to this in a little bit. Okay? So let's say, for argument's sake, that we're going to do this at 1 to 200. Right? I wish I could highlight this. I should have a live version that I can highlight. So if I did 1 to 200 right here, if I come across, right, 5/32 of an inch means my contour interval is going to be 31.250 feet. This will make more sense in a second. Okay? But also, if I come back here, if I'm going to cut out 11 by 17, right, that's what these are. These are 11 by 17 models. Okay? My size is going to be 2200 by 3400 feet. Okay, so I did the math for you, so you don't actually have to do the math. So let's come back to Rhino. And let me go in the top view, and I'm going to draw a rectangle that's at 3,400 feet, comma 2,200 feet. And I'll go ahead and hit Enter. Okay, so that gives me a nice rectangle here. Okay, that's the size of the model at 1 to 200 scale. Does that make sense how I reverse engineered that? Okay, so now if I were to move this over my terrain, I can decide what piece of this larger terrain do I want to cut out for my model. And so it would be helpful probably to turn on the shaded mode so I can kind of look down on the model. It may be helpful to look at it kind of, okay, where am I? The peak of the mountain's over here on that side. Yeah, let me get my X and Y orientation correct. There's X, Y, so they match up. It's over here right on that side. I can kind of see it there. So let me take my curve. I want to make sure that I include that peak, so let's move it over a little bit like that. Let's move it a little bit like that. Well, let's get both the peaks in. That'll be fun. Something like that. Okay? So you can kind of see that I'm trying to take this chunk that has that peak and this little lower hump in it. Okay? So I'm deciding what piece of the terrain I want to ultimately cut out. Okay? So once again, I'll go back to the top view where I'm looking at it in its large scale. I have a rectangle, but the rectangle doesn't match up with the topography yet. It's just floating in space there. Right? So if I'm going to work with this topography, I need to get this curve to match up on the edge. Right? And this is using a command that we've already done. It's project. So in the top view, I'll type project. I'm going to select the curve. I'll hit Enter. Then I'll select the surface, and I'll hit Enter. And the rectangle now goes up and down based on the topography. Does that make sense? So thus far, every time we've done the project, we had a flat surface, and we projected something that was complex onto the flat surface. This time, we're taking something that's flat and projecting it onto the curving surface. Okay? Once it's there, right, I can use it as a trim. So I'll type trim, and I'll get rid of this extra surface around it. And so essentially what I've done is I've gotten to the point where I have a surface that's in Rhino that is ultimately the size of an 11 by 17 sheet when I scale it down. Okay, so now I'm going to start to work with this a little bit more. So I got rid of the extra topography. I don't need it. I can get rid of this rectangle. I don't need it either. Now I have just the piece of terrain that I'm going to work with. So once again, let's jump back to this cheat sheet. I knew that my material thickness was 5/32 of an inch. And so you see that I gave you a variety of other thicknesses so that if you had a different material and you measured it, you could build it out of anything you want. Okay? This is 5/32 of an inch. I'm at 1 to 200 scale. So if I pull all the way across here to 5/32, right there, I get a contour interval of 31.250 feet. Okay? So that means for every 5/32 of an inch of thickness of the material that I'm going to build my model out of, right, the amount of feet that I have to go up in scale in my virtual world is 31.250 feet. So let's jump back to Rhino. And once again, I'm going to use the contour command. And I'm going to go, this time, of the object in the vertical direction. So we'll start at a base point here. And ideally, I'd pick the lowest point. It's probably there. And I want to make sure that I'm going up. So we'll zoom out, make sure that I'm going up. And my interval is going to be 31.250 feet. And so I'll go ahead and hit enter. And when I do that, it's going to slice up my piece of terrain, right, into pieces that I would go cut out on the laser cutter at the correct thickness. Does that make sense, how I reverse engineer it? So instead of saying, oh, each contour interval is 30 feet or 40 feet or something arbitrary, I'm basing my interval on the thickness of the material that I'm going to build the model out of. Right? That way I'm being precise when I make the model, and it'll match. So let me go ahead, and I'm going to change the layer that these are on. So let's change this. And I'm going to call this contours. Okay, there it is. And I'll go ahead and turn off the terrain surface so I have just the contours left. Okay? So again, if we jump back to here, this walks you through exactly what I'm going to do. Okay? And there's also tutorials, the video ones, that'll walk you through the same thing, so if you get lost. Okay, so let me come back here. And at this point, what I need to do is I need to make the sides of this material. Okay, so if you look at these physical examples, see how the sides step up and they step down to match up? Right? That's what I'm going to do. I have to make those little steps. Okay? And there's two ways of doing it. There's a way that on the surface is easier, and there's a way that on the surface is a little harder, but ultimately if you learn it, you'll be far better off. So I'm going to show you two different ways of doing it today. Everything, I know that what I've gone through is a lot to take in. We're going to have an exercise next class that basically goes through the whole thing again. Okay, so you're going to see this multiple times as you get used to it. So I'm going to go ahead and I'm going to do one of the shorter sides here in the first method. Okay, so I'm looking at this side here, and I want to make the steps that go along that side. So I'm going to come over here, and let's go ahead and change this layer. We'll call this Steps 1. I'll make that the active layer. So again, I'm being careful with my layers as I'm doing this. And I'm going to pick on the single point tool. Right? And actually, it's probably better if I do multiple points so I don't have to repeat the command. Right, so we'll do multiple points. And what I'm going to do is I'm going to put a point on the end of each of these lines. There, there. And I don't know whether that's in line. I think it's in line. Okay, I'm on the steps 1 layer. Okay, so if I were to turn off the contours, you'd see those little points, right? Those represent each of the corners of the lines. So I'll go ahead and turn the contours back on. Now what I'm going to do is select those points, not the curves. And starting at the lowest point, I'm going to go rotate 3D, and I'll set the axis right along the y-axis here. Okay. And I'll set this right along the vertical axis, and I'm going to fold those points flat. So you can see I started here, and I folded them flat. Okay. Now I can take my polyline tool. I can start at the first point, and through some dragging, I can draw the steps. All right, and so you can see that I have that set of steps. Now I can select that and this. I can go back to rotate 3D. Again, it's right along that x-axis, and we can fold it back up into position. And if I did it correctly, it should line up exactly on one edge. Okay, reasonably easy to do. Okay, but it involves creating all those points and then ultimately deleting the points and whatever. If I personally were doing it, I would use something that's slightly different. It's called Seaplanes. It's a lot like the UCS system in AutoCAD, if you understand that at all. Okay? And so this, I'm going off on a little bit of a tangent to explain this. There is a tutorial, I should point it out here. We go to Rhino 5.36 Seaplanes. This kind of walks through exactly what I'm going to talk about with how the seaplanes work. Basically, what happens... Oops, sorry. Didn't need that. Okay. What happens in the world of Rhino is that if we're in the top view, we're drawing on a plane that's at 0, right? That's flat. If we're drawing in the front view, we're drawing on a plane that's vertical, but it's flat to the front view. Okay? If I want to draw in the third dimension, going up this way with z's, right? If I tried to do it while I was in the flat horizontal ground plane at 0, it would be really hard to go up vertically and have it snap. So what I'm going to do is I'm going to change the working plane, the plane that I'm drawing in, from being flat on the ground to being vertical in this direction. And what I'll do to help show this is let me turn on, hold on a second, I want to try to show this a little bit better. I never have the grid on, but I'm going to turn it on for this. That was not what I wanted, but we'll get there. So let me go to grid, line count 2000, minor lines every 6 inches, major every 12. Okay, so see how I have a grid now that gives me an x and a y, right? That's representative of the plane I were to draw in. So if I just clicked on the polyline tool and I started to draw, right, it's always going to be in that plane because that's my active seaplane. If I change my seaplane, and I'm going to do that by clicking on this little triangle, going to set seaplane, and I'm going to do it with 3 points. You see that see how I get an x and a y axis that it's floating around? I'm going to start right here with my x and y. It's going to say select the x-axis. Okay, I want the x-axis going off in this direction. The y, though, I want to go vertical. So I'll switch my view and make sure that it's going up vertically. And you see how my grid changes from being on the ground to being in the vertical plane? This now saves me all the work that I did before with those points and the rotate and everything else because I can just click on the polyline tool and start drawing in the vertical dimension. Oops. And do the same snapping that I did flat, but this time while it's in place. So it's a little bit more work. Conceptually, it's a little bit harder to understand, but once you master it, it makes modeling significantly easier. So I would continue up the side, and bear with me, I'm actually going to finish this side. Okay, so this presents an interesting point right here. So see how as I'm coming up, I get to a point where I have one contour that's even with another contour, right? This is indicative of instead of going up again, I'm going to go straight across and then I'm going to start going back down, right? The opposite is true at a valley. You're going to end up going down and then straight across. And so there's always going to be a few tricky points. Today I want you to get the bulk of these lines correct, and then we'll go through on an individual basis and make sure before you move on that you've done the sides correctly for the valleys and the complicated pieces. Oops. One more. Okay, so now I have a set of steps, right, that go up and down that side, and my seaplane is still in this dimension. Right? If I were to look at it in one of my side views, there it is. if I did it correctly, it should look like steps. There shouldn't be any angles. It should be straight vertical, straight horizontal. Okay? So now I have that drawn. Okay? If I go back to my perspective view and I went to start drawing over here, right, it would be very difficult because my seaplane isn't in plane with the direction that I'm drawing. So I'm going to set my seaplane back to the original and then reset it. It's much, much easier to always go back to world top, which is the default, and then reset a new seaplane. So instead of just jumping to a new seaplane for this side, I'm going to set it back. So I'll go to set seaplane, world top, puts it back to where it is at 0, 0, and then I'll go to set seaplane, 3 points, and I'll start right here. This time the X is going to go in that direction, and the Z needs to go vertically again, so we'll come over here, make it go vertical, and now I've flipped into that view and I can continue with my steps. Okay? So it's just important to go back to the world top. That's always the default. Right? And so to me it's a lot easier. You're less likely to get screwed up and have your seaplane be on an angle or something weird if you go back to world top in between. Okay, so I know I put a lot on you today, and there's a lot of steps. I don't anticipate that everybody will get through with everything. Okay, this is the nature of this. It takes time for you to learn. This is more complicated than anything you've done yet, right? But I want you to go through this process and get as far as you can, and I'll come around and help you however far you've gotten. I will repeat everything and then take it a couple steps further. So if you went to the tutorials, right, and you went back to the physical modeling one here, right, there it is, right, I stopped today right here at step 9. We're done at step 10. Okay? So we will pick up at step 10 and continue next class. Okay? So you don't have to get all the way through where you are. And so if the dot method makes more sense or the seaplane method makes more sense, it's up to you as to which one works mentally for you. Okay? So I'm going to turn you loose, but I'll come around and help you because I know that there's a lot of sticky points along the way.